Okay, welcome everybody. I'm going to be talking about mastering the art of T-SQL debugging. So just a little bit about me. My name is Simon Frazer. My pronouns are he, him. I was a developer for a long time, about 14 years, gradually moved into the database space, primarily worked with Microsoft SQL Server. I work for a company called Medivet. I also have my own company on the side, Simon Frazer Limited, and there are some contact details there, which I can also share in the chat window. So what we'll cover, so I'll talk a little bit about when debugging is required with T-SQL, talk about very simple print statements, then how we can leverage raise error for debugging. That's quite an interesting one. Then we'll talk about how table variables can help, and also environment considerations as well, because that's important. So before we get into the demos, when do you need to use debugging? So there are various types of scripts. Very simple script will be a select statement where you're selecting a handful of columns from a table, say maybe selecting customer information where customer ID equals 1, 2, 3, 4. Very basic. Debugging that isn't too difficult. Either the syntax is wrong, in which case the tool you're using will probably tell you, or you've got your where clause wrong, you got the wrong ID or something like that. When debugging is required is more when you've got complicated scripts. For anyone working with T-SQL, I'm sure you've come across scripts that are sort of hundreds or thousands of lines long, potentially. They do various different things. They might have conditional logic in there. And that might be for an application stored procedure. It might be a report or an ETL process. But also it might be a maintenance script that a DBA would run. So if you need to do sort of bulk data manipulation overnight, or moving data around, or even just database maintenance, if you've got something sort of fancy that sort of does indexes and all this kind of thing. So that's when debugging these scripts becomes essential, really, because it can get quite complicated. In Visual Studio, in the developer world, you get really good tools to sort of debug things. In the SQL Server world, you used to be able to do a similar thing in Management Studio. They kind of took that away. There are good reasons for that, and I won't be going into that really for this one. Where's my demos? They are over here on here we go. So you'll see these at the top of my scripts. It just stops me hitting F5 and running the whole lot, because I want to run these one by one. So you can kind of ignore that for now. The very simply then, and people who know T-SQL probably already know this, but a select statement will come out on the results tab there. A print statement comes out on the messages tab. And that's an important distinction that we'll sort of use going through. Print statements, you can print out date, times, numbers, obviously text, and then you can also declare a variable, and you can see the value of your variable in a print statement as well. F5. So let's see where we would use that with debugging. So I've got a kind of a conditional statement here, and this is a rather sort of made up example. It's just to show some conditions. You wouldn't really do this in a production environment, because I've told it which logical path to follow there. But let's say you've got a manager, he wants some report that shows him a very important number that helps him make business decisions. The logical path will sort of go through and do some clever things. Again, these calculations are all just made up. But at the end of it, you get a number, you give it to your manager, and he says, no, that's way off. Something must be wrong somewhere. So imagine this was sort of hundreds of lines long. To very quickly debug this, you can just put print statements inside each of these logic blocks here. So if we run it again, you get the same result, obviously, but it then tells you part 2 is where the logical path flowed through. So it came into this section. It's not as fancy as you get in Visual Studio, where you can step through in the debugger, but typing out that is very, very quick. It very quickly got me to this section, so I can work out what's wrong with the calculation there. Limitations of the print statement, though. If I were to output these 3 statements, and I've just forced a 3-second delay between, they'll come on the messages tab. So we've got 3 seconds, nothing, 6 seconds. So they go 9 seconds. So all 3 of them only show after 9 seconds. And if you're sort of trying to debug a script that takes a long time to run, especially a maintenance script that might take hours to run overnight, you don't really want to be sitting there waiting for these statements to come up. So next we go on to raise error. Let me just check my timer. Are we good? So you might think, why raise error? That's for raising errors. But it's actually quite useful. It's been sort of replaced by a command called throw now, and we'll see that down below. But you can pass in a message, a severity, and a state. The message is whatever you want. The severity is shown here, and I'll get onto that. And the state is kind of user defined. You can associate that with something. It can be a number that is meaningful to you, but we'll ignore that for now. It's not really important. But different severity levels do different things. And this table was actually created by my boss, Greg Kirkham. Thank you for that. Just to kind of explain what these do. You can also go to Microsoft Learn's site. There's a link there, and I'll share these slides so you can kind of read up on raise error a bit more. So raise error basically throws an error to the screen. It's nice and red. When you do it inside a try catch block, and if people haven't seen these before, any code with inside the begin try and the end try will start to run, and if any errors happen, it will come down inside this catch block here, and I'll show you that happening. So we start off with the print statement comes out, but then we get something broke, and that's because that raise error has stopped the execution at that point and come down to here. And this is the throw that I'm talking about. This just throws the error back out of the catch block onto the screen. And this is one Microsoft recommends you use. You could use throw here as well. The important thing is the severity. In this one, I used 16. Down here, I'm using 0, which is a lower severity. And when we run the same code, it raises the error to the screen, but it carries on the execution. It doesn't jump to the catch block here. So it's a low severity error. It's more just like an informational warning. And if we run the same example that we had in the print script, where it outputs 3 messages to the screen with a 3-second wait in between, we'll see what happens. Sorry, need a drink. So I'll run that again. So you see the errors come out after 3 seconds, you get the second one. After 6 seconds, you get the third one. So as soon as you run that command, the error gets displayed on the screen, whereas print would, you get all 3 at the end. And that's because this section here is absolutely brilliant. When I found this, it was a real game changer for me. Adding with no wait at the end and having a low severity, that combination, it gets messages on the screen in real time. And then a little bit more about these. You can kind of concatenate things together. There's a substitution here. I won't go into that because it's a bit complicated, but that string basically means that variable. So you can say the value of my variable is this. Very useful for debugging. If you want to see the value as a variable, it might change throughout the script, so you can keep track of that in the messages window. And then also I find it's extremely useful. You can add a timestamp as well. So if all your messages have this timestamp, you can see when things happened And you can see the duration in between. You can sort of work that out. So now on to a more advanced example. This is using the Stack Overflow database, which you can download for free. I'm on SQL Server 2019 here, and I'm using this Management Studio 21. Let's say somebody says to you, we don't want rows in the comments table where the user ID is null. They shouldn't be there. Please go and delete them. This script, it looks quite complicated, but it basically loops through that table, deleting a certain number of rows at a time. We don't want to delete all of them, because if there are thousands, you could cause problems with the transaction log bloating. You can cause blocking with your application, especially if this is a production environment. So we're gonna delete them in batches. I've set my batch size to 1,000 up here, and it works out sort of how many rows there are to delete, and it's got a little 5-second delay just so we can see what's going on. So if I run this, and this is where the real use of raise error with no wait comes in. I've got my script started. That's the number of rows I want to delete. And you can see it kind of chugging through here. And I've added a percentage there as well. So eventually that will just delete all the rows. And if there was a problem here, you could add further messages in if you wanted to sort of debug. But it just shows you how useful it is to get information on the messages screen in real time, especially if this is something running overnight and you're having to babysit it out of hours. So lastly, temporary tables. They're good if you want to keep track of your variable values. You could create an actual table, but if you're in production, you might not be allowed to create tables anywhere. So if you create a temporary table, you can sort of store things in there as your script's going along. The reason I use table variables over temporary tables is if we create this temporary table, insert rows into it in a transaction, and then select from it, yes, we get those rows. But if you do the same, but roll back the transaction, the temporary table's still there, but the inserts get rolled back. Now, if you were in a script that had a try catch block and it dropped to the catch block because of an error, and roll back a transaction that you had, you lose all the nice debug information you've put in here. So you can't then play around with it at the end. If you do the same with a table variable, if I commit, we get the rows, but if I roll back, we still get the rows. And that is because variables are not affected by transactions. And that's any variable, not just table variables. And so it means that it doesn't matter what's going on your script. If you're committing, you're rolling things back, you can still have that data at the end, and you can do whatever query you want on your debug data. You can where clauses and kind of chop and change that. So table variables again are really useful. And we don't have time. We're okay. So the last point I want to talk about is environmental considerations. If you are doing this in production, there is a high risk you will break something. Your company might even have a policy where you're not allowed to just change things. They should have that policy. Sometimes I create a sort of a separate database and I can do things in there on a production server. But if you are debugging a stored procedure, there are a couple of things you can do. I highly recommend not just editing the actual stored procedure. You can create a copy of it, and my preferred method is to put your initials in front of it. And again, this is a basic stored procedure. But if you did that and then you can execute that, it works fine. And you can then start putting sort of print statements, raise error statements, chopping and changing it. Again, don't change it so much that it sort of starts updating rows where it shouldn't be, because you're just sort of testing and debugging. You can create a temporary stored procedure. I don't do it very often, but it's possible. You can use the hash notation the same way you would with a temporary table. So that would work. You can also do a global temporary stored procedure with a double hash, same that you can do with temporary table. I don't know why you would want to do that, but if I created this, I could then open another session and it would find that and execute that. Whereas with these, they only live for as long as my session is active. That's why you might, if you can, want to go for a more permanent table if you're doing lengthy debugging and you want that data to persist somewhere. So if you lose your connection, you don't lose all your debug information. If you're in lower environments, sort of dev and QA and UAT, you still need to be careful because somebody needs that for their job. It's in use. It's not sort of business critical. So you can maybe get away with altering sprocs or creating tables. And then the other option, and again, this is one I do quite often in production. If you've got a stored procedure, just take the code out of it, put it in a screen like we have here, and save it and play with it like that, really. It's a bit of a faff. Again, Visual Studio has many more things to help with debugging, but unfortunately in the SQL Server world, it's difficult because if you're stepping through a script and you pause it like you would in Visual Studio where you got the breakpoints, you could essentially be blocking all kinds of things whilst you're paused on that line. And I think that's probably one of the main reasons they took it out of SSMS in the past. And that's pretty much it, really. We'll flick back to the slide. So I just got some contact details there. I can share them in the chat. But are there any questions at all?